Good evening, my dear students. So today in this sessions we are going to learn fourth problem on the step bar. Determine the first condition in this problem is nodal displacement we need to determine. So the nodal displacement nothing but we need to find out the value of Q1, Q2 and Q3 because we have the three node, first node, second node and third node. For that reason we need to find out the value of Q1 and Q2 and Q3. Okay, and second condition in which we need to determine the stresses and strain. So let us see this figure. So in which, let's see this figure. We have how many nodes? First node, second node and third node. The first node in the second node lies between one element, what we can say E1, and second node is connected to the third node. It lies another element we can say as E2. What we can say, dear element? E2. So this means that we have two elements. So for that reason we need to find out the value of sigma 1 E1 for the first element, for the first element. For the second element we need to find out the stress value of sigma 2, strain E2 we need to find out. Okay, third condition. In the third condition, the reaction at this support. So this means that we have three node. Is it right? This is the first node, second node and third node. So in this case what we need to find out, that how much normal reaction is acting at a point of 1 and how much normal reaction is acting at a point of 2 and how much normal reaction at a point of 3. So in this case we need to find out. Okay, let us see this figure. The figure, it is looking like a step bar. So the one end of this bar is rigidly fixed and another end of the bar on which the load 200 kilonewton is acting at a point of 1. Okay, so the element 1 of it is total length. How much is given here? It is given as 400 mm. How much length is given here? 400 mm is given. And is it right? And the area of the first element, it is given as 600 mm square. The joining the first node to second node, the forming of element we can say as E1. What we can say? E1. Okay, and second thing, the joining the node from the second node to the third node, the forming of element we can say as E2, small e2. This element second of its length is how much is given? It is given as 300 mm. And the area of cross section of the second element, it is given as 2400 millimeter square. Okay, so the first of all we need to solve the problem. First of all we have to write down the given data. We have two element, first element and second element. For element number 1, the area of element, it is given as 600 mm square. Okay, the length of the element is given as how much? This one, what we can say, length of first element, how much is given? 400 mm is given. And modulus of elasticity or Young's modulus value is given as 200 gigapascal. Always remember, if it is given, it's okay. If it is not given, then you need to assume the value of 200 gigapascal. How much? 200 gigapascal. So 200 as it is. Giga means how much dear? Generally we know very well giga nothing but, okay, don't go for this one, go for here only. Giga nothing but 10 power of 9. How much? Giga nothing but 10 power of 9. So 1 Pascal equal to 1 Newton per meter square. 1 Pascal is equal to 1 Newton per meter square. 200 as it is into 10 power of 9 as it is. 1 meter equal to how much dear? 1000 mm. Is it right? So here meter square will be there, means here 10 power of 3. So 1000 we can represent in the form of 10 power of 3. 1000 we can represent in the form of 10 power of 3. So here square will be there, we have to make as square. 1 meter square is equal to 1000 mm square. Mm square as it is. 3 2s are how much? 6. This 10 power of 6 as well as this 10 power of 9 will cancel. Remaining should be how much dear? 3 is remaining. 200 into 10 power of 3 Newton per, this cancel now, the remaining should be how much? Millimeter square. If you want to remove this 2 digit, then it is make as the power is 10 power of 2. How much? 10 power of 2. Then we can represent like here 2 into 10 power of 5. How much? If the bases are same, then power should be added. This 3 and this power is how much? 2. Should be how much? 2 into 10 power of 5 Newton per mm square. Same as it is here. E2 equal to 200 gigapascal should be how much? 2 into 10 power of 5 Newton per mm square. Over here. Come to the point of element number 2. Okay. So this cancel this one because this is wrong. This one 200 into 10 power of 5. The actual answer is 2 into 10 power of 5 Newton per mm square. Okay. I hope so you understood. For element 2, area of element, how much is given? Area of element A2 is given as 2400. It is given. Okay dear. And the length of the element, how much is given? The length L2, it is given as 300 mm. It is given. And E2 already we know very well. Okay. After that, we need to find out the first step is finite element model of a given body, or we can say as given continuum. Let us see. This is a first node, second node and third node. First draw one line. Okay. First node, second node, third node. Of the length from node 1 to node 2 of its length, how much is given? 400. It is represented by L1. And node 2 to node 3 of its length, it is represented by L2. Okay dear. And the force, okay, how much load is acting at the node 1? 200 kilonewton. Okay. So the Q1 is represent that the nodal displacement is acting at a point of 1. It is represented by Q1. And F1 is indicate that the nodal force vector, it is acting at a point of 1. It is represented by F1. And Q2, the Q2 it is represent that the nodal displacement is acting at a point of 2. It is represented by Q2. And the nodal force vector, it is acting at a point of 2. It is represented by F2. And the nodal displacement is acting at a point of 3. It is represented by Q3. And the nodal force vector, it is acting at a point of 3. It is represented by F3. So where Q1, Q2, Q3 are the nodal displacement, Q1, Q2, Q3 are nodal displacement, F1, F2, F3 are nodal force. F1, F2, F3 are nodal force. In the step number 2, we need to determination of elemental stiffness matrix. So in which K is indicate that elemental stiffness matrix should be equal to AE EE by LE 1 minus of 1 minus 1 into 1. If you want to find out, because how many element we have two element 1, element 2. First of all, we need to find out the element number 1. For element 1, K1, instead of E we have to represent the 1. The element is, for element 1, K1 equal to, wherever E will be the small e, we have to represent the 1. A1 E1 by L1 1 minus of 1 minus 1 into 1. The area of cross sections of the element 1, how much is there? It is given as here 600. Okay, 600. The Young's modulus, how much is there? 2 into 10 power of 5 by length. How much? The length of the first element is given as how much? 400 mm. 400. 1 minus 1 minus 1 1. So if you divide this whole the value, then you will get the answer is 3 into 10 power of 5. Just if you multiply direct then it should be how much? 3 into 1 should be how much? 3. 3 into minus 1 it should be minus 3. 3 into minus 1 should be minus 3 into 3. Okay, that is the value of for the element 1, elemental stiffness matrix. After that, elemental stiffness matrix for the element 2 we need to find out. We need to find out the value of K2. We need to find out K2 equal to A2 E2 by L2 1 minus of 1 minus 1 into 1. So let us see, A2 value is given. How much is given here? 2000. Let us see, A2 value is given as 2400 is given. 2400. E2 is 2 into 10 power 5. L2 value is how much is given? 300 mm is given. Same 1 minus 1 minus 1 into 1. So if you divide the whole the value, how much you will get? 16 into 10 power of 5. If you multiply this one, it should be how much? 16 ones are 16. 16 ones are should be how much? Minus 16. This is should be minus 16. 16. That's it. After that, in the step number 3, we need to determine the global stiffness matrix. So this means that we need to find out the value of K1 as well as we need to find out the value of K2. We need to find out. So here K1 how much we got here? 10 power of 5. 10 power of 5 we have to represent here. 3 minus 3 minus 3 3. Okay, plus as it is K2 is 10 power of 5 16 minus 16 minus 16 16. Then let us see over here for the element 1, for the global stiffness matrix. If you want to represent this, capital A's indicate global stiffness matrix should be equal to elemental stiffness matrix for the element 1 plus elemental stiffness matrix for element 2. So here for the element 1, how many nodes are there for element? First and second. First and second. First node, second node, plus 10 power of 5 as it is. This is if you want to join element 2, then which one we have to join? Element second, element third. Let us see this figure, then you can easily understand. If you want to join first node to the second node, then you forming which element here? Element number 1. First node, second node. So it is represented by K1. If you want to join the second element, then you need to join second node and third node. Second node and third node. Then you can easily get the value of elemental stiffness matrix for the element second. We can easily find out. This is the second node, third node, second node, third node. Total we have to arrange in the sequence manner. How? We have to join the first node to the second node to the third node. Total how many nodes we have? We have 3 nodes. So first, for that reason, we have to represent in this sequence order. This is the first node, second node, third node. First node, second node, third node. First of all, you have to represent. After that, how to multiply, that is the most important. First of all, we have to multiply in such a way that, so one first node to first node value, how much we got here? 3. First node to the first node, we are getting the value is 3. First node to the second node, you are getting the value is -3. Here first to third node is there? No, first to third node is not there. If it is not there, then we need to represent the value is 0. Okay, over. Come to the second node. Second node to the first node. Come to the here. Second node to the first node. What is the value is there? -3. Okay. Second node to the second node value, how much is there? 3. That is over. Come to this point. Second node to the second node value, how much will be there? 16. We have to add this 3 as well as this 16, because both are same. 2 node, second node, second node, second node. We have to add here. Over. After that, you need to multiply second node to the third node. How much? -16. Again, third node to the first node. Third node to the first node should be how much? 0. Third node to the second node, how much should be? -16. Third node to third node, how much should be there? 16 only. Is it right? 10 power 5 as it is. This is 3 -3, 0 -3. If you add 3 plus 16 should be how much? 19 -16, 0 -16, 16. After that, what we need to find out is step number 4. We need to find out. In the step number 4, what we need to find out? We need to find out the displacement vector as well as global force vector. We need to find out. So here, how many nodes are there? 3 nodes. First node, second node, third node. The Q, what they represent? The Q represent the displacement vector. So here, how many nodes? 3 nodes. So for that reason, we can represent here in the matrix Q1, Q2, Q3. And the nodal force vector, it is represented by F equal to F1, F2, F3. F1 value, because the load is acting where? At the free end. But I told you where the X is acting. So let us see this figure. This, we are applying the force here. We are applying the force which side? This is the tensile load. Okay, but X is which load is the displacement? X should be which direction is will be there? Opposite direction. For that reason, this value should be how much? This value become minus. Tensile value will become which one? Minus, because this X is acting in the opposite direction. If it is acting in the same direction, if it is acting same direction, then we can consider this value is plus. Okay dear, come to this point here. Here F1 value is how much? -200 into 10 power 3. Force F2 is how much? 0, because we don't know how much force is acting at the node 2. Because do you know? We don't know how much force is acting at the node of 2. But if it is fixed, means compulsory should be 0 only. The nodal force should be here 0. F2 0, F2 0, F3 also 0. Then that is over. After that, what we need to find out? We need to find out the equilibrium equation for a given continuum. We need to find out. If you want to find out the equilibrium equation, let us see 10 power 5. This is a K value. What the K's represent? The K represent the global stiffness matrix. Q represent the nodal displacement vector, should be equal to the nodal force vector. How to remember? KQ equal to F, KQ equal to F, KQ equal to F. That's it. You have to remember in the mind. Okay. Then K value is how much is there? 10 power 5. This value is already given. How much is given? Let us see over here. The global stiffness matrix is given as K equal to 10 power 5, 3 -3 0 -3 19 -16 0 -16 16. Okay, it is given. Q, nothing but the nodal displacement vector. We have Q1, Q2, Q3, Q1, Q2, Q3 equal to the nodal force vector is -200 into 10 power 3 0 comma 0. So here which one is the fixed end here dear? Node 3 is the fixed end. If node 3 is the fixed end, the Q3 value should be how much? It should be 0. It should be how much? It should be 0. If it is 0, then we need to eliminate third row, third column, third row, third column. The remaining should be how much? 10 power of 5. In the step number 6, we need to apply the boundary condition. So this method, what we can say, elimination approach method. What we can say, elimination approach method. So generally we know very well node 3 how is it fixed. If it is fixed, will be there. Q3 value should be how much? Generally we know very well it should be 0. That after that we need to eliminate this third row, third column. Okay dear, 10 power 5 as it is. The remaining should be how much? 3 minus 3 minus 3, 19. Q1 Q2 equal to minus 200 into 10 power of 3, 0. After that 10 power of 5 as it is, just you need to multiply 3 into Q1. Always remember this horizontal row into column, row into column. 3 into Q1 minus 3 into Q2 equal to minus 200 into 10 power of 3. So in this case we are solving one by one. Okay, I'm taking this above value only. After that I will take below value only. Okay, then if you divide this whole value, then you will become 3Q1 minus 3Q2 equal to minus 2. So it is considered as equation number 1. After that let us see 10 power of 5, this row, below row into this column, minus 3 into Q1 plus 19 into Q2 equal to, what is the value is there? 0. 10 power of 5 by 0 should be how much? 0 by anything should be how much? 0. Then 3Q1 plus 19Q2 equal to 0. It is considered as equation number 2. So first of all we need to equate the equation number 1 and 2. So 3Q1 minus 3Q2 equal to minus 2 minus 3Q1 plus 19Q2 equal to 0. So if you are cancel these terms, then should be how much? So 19 minus of 3 should be how much? 16. Q2 equal to minus 2. So Q2 equal to, if you divide this term, then you will get the answer is minus 0.125. So after the getting the Q2 value, we need to substitute in the equation number 2. Equation number 2 is, which one is there? Minus 3Q1 plus 19Q2 equal to 0. Minus 3Q1 plus 19Q2 equal to 0. Minus 3Q1 as it is plus 19 as it is. Q2 value how much? Minus 0.125 equal to 0. Minus 3Q1 plus into minus should be how much? Minus 19 into 0.125 equal to 0. Minus 3Q1, if it is moved toward this side, means it should be become as positive. Q1 equal to minus this minus 19 into 0.125 by 3. If you divide this whole the value, then it will become minus 0.791 mm. That is the value of Q1. Okay dear, we got the value of Q1, Q2 and Q3. Q1 value is the minus 0.791, Q2 value is minus 0.125, Q3 value is how much dear? It is 0 because of it is the fixed end. Clear? After that, step number 7. In the step number 7, determination of stresses and strain we need to find out. For which element here? For element number 1. So strain equal to E1 equal to B into Q. So the this B matrix, it is represented by 1 by L1, because already I told you here we have how many element? We have 2 element. First of all we have to solve the strain for the first element, as well as we have to solve the stress for the first element. After that we need to solve the strain for the second element, as well as we need to solve the stress for the second element. Here in this case, this is for the first element, 1 by L1 minus 1 Q1 Q2, 1 by 400. The length of the first element is 400 minus 1 into 1. Q1 value is how much is that here? Minus 0.791 minus 0.125. So after that, if you are multiply this value 1 by 400, minus into minus should be how much? 0.7 and 1 plus 1 into minus 0.125. If you divide the whole the value by 400, then you will get the answer is 1.66 into 10 power of 3. That is the value of strain for the element number 1. After that, we need to find out the value of stress for the element number 1. Sigma equal to E1 into B into Q. Let us see E1 as it is. The B into Q, it is represented by strain how much? E1. So modulus of elasticity of a material, how much is given here? 2 into 10 power of 5 into, so strain value how much is given? 1.66 into 10 power of 3. If you multiply this term, then you will get the answer is 333 Newton per mm square. That is the value of stress. After that, we need to find out for element number 2. Strain E2 is equal to B into Q, 1 by L2, 1 minus 1 into 1. That is the value of B. What is the value of Q? Q2, Q3. Is it right? Because we are joining the node second to third, they forming of element second. Is it right? 1 by 300 minus 1 1. Q2 value is how much is there? Minus 0.125. Q3 value is how much is there? 0. After that, 1 by 300, just you need to multiply these terms. Minus 1 into minus 0.125 plus 1 into 0. If you divide this value, then you divide the 300, then you will get the answer of strain is 0.416 into 10 power of minus 3. After that, we need to find out the stress for the element number 2. Sigma 2 is equal to E2 into B into Q. E2 as it is, B into Q, it is represented by strain E2. So modulus of elasticity of the material 2, it is given as 2 into 10 power of 5 into E2 value is how much is there? 0.416 into 10 power of minus 3. And that is the value of sigma 2 equal to, if you multiply this whole the value, then you will get the answer is 83.33 Newton per mm square. After the getting of the stress of sigma 1 E1, sigma 2 E2 already we have solved. After that, we need to find out the reaction at this support. We need to find out. So we know this method. What is the formula? R is equal to KQ minus of F. R nothing but the normal reaction is acting at a point of 1, 2 and 3 equal to the global stiffness matrix. K represent, Q represent the nodal displacement vector. So here we have 3 node, we have to represent as Q1, Q2, Q3 minus F1. F is indicate that the nodal force vector F1, F2, F3. So the global stiffness matrix value is how much is there? 10 power of 6. Okay, 3 minus 3, how much is that here? 10 power of 5 now dear. I hope so. I did the small mistake here. Here not the 6 dear. Remember, not the 6, here 10 power of 5. How much? 10 power of 5. Here also 10 power of 5. Here also 10 power of 5. So after that, how to multiply this value, that is important. If you want to solve the value of R1, because you can expand also, but I'm not doing, I'm simplifying each value, then you can easily solve the problem. For that reason, first of all, you have to go for R1 value. R1 equal to, not the 10 power of 6, you have to represent as 10 power of 5. Okay, 3 into Q1, 3 into Q1 minus 3 into Q2, this row, first row into this column, minus 3 into Q2 plus 0 into Q3 minus, as it is, the first one is minus 200 into 10 power of 3. So Q1 value, how much is that here? 0.791 minus 3. Q2 value is how much is there? Minus 0.125 plus Q3 value is 0 only. Is it right? Minus 200 into 10 power of 3. 10 power of 5 as it is. If you multiply this value, then you will get the answer is minus 2.373 plus minus into minus should be plus 3 into 0.125, then you will get the value is 0.25 plus minus into minus should be how much? Plus 200 into 10 power of 3. If you add this whole the value, this value, then you will get the answer is how much? 0 Newton. So minus 2.373 plus 215, multiply 10 power 5, then you will get the answer is minus 200 into 10 power 3. So this is already is there 200 into 10 power 3. If you, so both are same, here minus is there, here also plus will be there, this value should be cancelled, then you will get the answer is how much? 0 Newton. Okay, after that what we need to find out? R2. How to find, that is important. Take this R2 value, R2 here, 10 power of 5 as it is. Take this second middle point, this row, second row into this column, minus 3 into q1, minus 3 into q1 plus 19 into q2 minus 16 into q3 minus 0. 10 power 5 as it is, minus 3, q1 value is minus 0.791 plus 19, q2 value is minus 0.125 minus 16, q3 value should be how much? 0, minus of 0. So if you multiply, minus into minus should be plus, 3 into 0.791, you will get the answer is 2.375. Plus into minus should be how much? Minus 19 into 0.125 should be how much? 2.375. Then if you are 2.375 minus of 2.375, it should be 0. 0 into anything should be how much? 0 over. Come to the point of R3. R3 equal to this row, third row into this column. Okay, so 0 into q1, 0 into q1 minus, okay, 16 into q2, 16 into q2, okay, plus 16 into q3, plus 16 into q3 minus of 0. Okay, here after that 0 into anything should be how much? 0 minus 16 as it is. Q2 value is how much is that here? 0.125 plus 16 into q3 should be how much? 0, minus of 0. So if you are multiply minus into minus should be plus, 16 into 0.125 should be how much? It should be 2. So if you multiply this terms, it should be how much? R3 value is 2 into 10 power 5. So we got the value of R1, R2, R3, sigma 1 into E1 and stress value, as well as stress for the element 2 is sigma 2, E2 we are find out. Is it right? As well as, so in the result you have to represent, because it is a carrying for minimum 2 or 3 marks. Is it right? So if you explain, so if you write up to here, then you will get the full marks. Okay, the external examiner, he will not get the single marks also. Remember one thing, for that reason you have to represent this result. Okay, the nodal displacement are q1 how much is there? Minus 0.791. q2 how much we got here? Minus 0.125 mm. q3 how much we got? Because q3 is already 0, because it is a fixed end. The nodal displacement value q3 should be 0. After that we need to find out the value of how much maximum stress are induced in the step bar. So sigma 1 value how much is there? The maximum stress is induced in the first element is 333 Newton per mm square. The maximum stress is induced in the second element is 83.33 Newton per mm square. And the third condition is the reaction at the support. R1 is 0, R2 also 0, R3 value how much we got here? 2 into 10 power 5 Newton. I hope so no one is having the doubt. And you guys please like, share and subscribe my channel. Thank you.